do it and it doesn't happen.
Right. Okay, well, let's go ahead and get started.
How's everyone doing? Good.
Welcome to day 2. Could we see a quick show of hands? Who does not have a laptop with RStudio loaded up and ready to go? No one. Excellent. Okay, is that, yeah, okay. Are you going to just be following along without laptop? Okay,
Sounds good.
All right.
So I'll introduce myself. My name's Robert Mitchell. I was formerly with Skid Row Housing Trust. Yesterday was my last day. So today is actually my first day with Los Angeles County, working at the Department of Health Services for whole person care. So if anyone's at the county, come say hi. Looking forward to meeting everyone. And then Lauren, you want to?
Yeah, so I'm Lauren Steele. I work with the Metropolitan Water District, which is a municipal water supplier, and I'm a water policy analyst there.
So there are 2 talks that we're doing together, and we felt like the best method for splitting these things up is to kind of focus more on the reproducibility aspects in this talk, and then how those dovetail into Shiny in the later talk. So this is really going to focus on the reproducibility aspect of working with R and doing analysis in R. This is the GitHub repository you can use to clone the materials. The slides are also there.
Does everyone know how to, in RStudio, set up a new project and then clone a GitHub repository? It's really easy. Okay, I see some people shaking their heads.
Right.
Let's just walk you through it because it's pretty simple. You are going in RStudio, you're going to go to File, New Project, and then choose Version Control. And then say Git. And then in this URL box, you're going to enter this URL. New project, version control, Git.
For those of you that are a little more familiar with Git and the command line, you can just git clone the URL. I've actually never done it this way.
Oh,
Yeah.
I've actually never done it that way because I'm not a command line person.
This is a good combination of experience.
Yeah.
Is it accessible through your shell? Are you using, what environment are you using? On a Mac? See if Lauren can troubleshoot you. Is anyone having issues right now? You are? You can just download those files into a directory. You don't need to plug it necessarily, but the files will be there. You can still work with it in Studio. You just don't need to yeah. It's just always study it. We have some examples for it. We didn't work here yet. So yeah, so you can add your path if you're having issues with Git. Also, too, if this is your first time working with Git, this is very normal. The feeling of why isn't this working happens a lot with Git. So what you can do also is you can go to that URL in your browser and just download the files. You don't necessarily need to worry about Git if you're not going to be contributing or committing new changes. So you can also do that as well. Because the R Markdown documents, everything is there. It's really just, you know, if you're familiar with Git, this is an easy way to get all those files quickly. But you can do the old-fashioned route, go in, download them all. And if you don't necessarily want to follow along with the R scripts themselves, you can browse through the GitHub URL. So GitHub works with a user interface on the web, and you can click through the directories and download individual files as well. HTML files, they're already rendered, so you can explore those when we get to those spaces. Sure. So let's do that. So you'll have to forgive me. Oh yeah, that's right. I'm losing my vision and the text is small. So see right here, the screen box, this is clone or download. You can download this in a zip, or if you already have the GitHub application installed, you can download it that way as well. And it'll save it as a zip. You just need to unzip it and then you're good to go. And you can open the R project file in RStudio. So if you go back here, there's a little square right up here in the corner, and you can open projects this way. I'll leave that there just in case you need to see it. Does anyone else have any other questions? Having some difficulty? If this seems overwhelming also right now, that's okay. Don't feel bad. Working with Git and RStudio projects initially can seem that way. And so what we're mostly talking about is, you know, how to structure projects so that they work reliably in the way that you expect long term. So I'm going to get started if everyone is okay. So the basic synopsis is that as an analyst, often you spend hours working on an analysis. There are ups, there are downs. You've tried visualizing things in many different ways. You've tried gaining insight in many different ways. And so there comes a point where you need to share this work with your colleagues, with stakeholders, with your boss, or like in my case, where I'm leaving an organization and going to a new one, I want to make sure that whoever comes after me is going to be able to look at my work and understand how it works. So we want people to be able to reproduce our work, right? Just like in science, reproducibility is a big important issue, because if results can't be reproduced, then there's some doubt to the credibility of whether or not you can trust them. But let's take a step back right now before we get down a rabbit hole so much. Really what we're trying to avoid is files like this. So take a look at this Excel file and then ask yourself what you think is wrong with this picture. And feel free to talk to your neighbor and brainstorm about what you think is wrong with this file. It's okay, we can start talking and it doesn't have to be so quiet. Huh? It's not, okay, well, let me see. This probably works. No, it doesn't. No. I can't necessarily zoom it right here. Let me see. Here we go. Yeah, that doesn't do anything. So, sorry, I can't zoom this in, but you can open this image. It's in the images directory if you've cloned the documents, and you can open it on your computer and zoom in. But you don't need to look too deeply at, it's not necessarily the text. So does anyone want to hazard some guesses about what's going on, what's wrong? Right, so merge cells. Yeah? Exactly. Exactly. Yeah, so there are three things that we can kind of focus on, and this is from an example of like what not to do with an Excel document. You know, don't use color text or cell shading, because really this is metadata, right? We're saying something about this cell. We're saying this is important in some way, but in what way specifically? And this is an issue because colors don't mean something to someone. They're quite arbitrary, right? Unless you assign it a value. People can pick certain colors that they like or don't like to represent certain things, and that's all just not accessible, right? Commas, right? So when you have data in a cell with a comma and you want to make this machine readable, it's going to create a lot of issues because those extra commas are going to be read as separate entries. So like a common example here is when you have city and state together in one cell. Like these are technically two variables, right? Or columns. And you want to retain that information in your data. And like was mentioned, merging cells, right? And this can often get misread. And you know, here we have cells in column 1. They should be unmerged, and the data information entered into the first cell should be in each row. And this is from Software Carpentry. If you've ever seen they have plenty of awesome tutorials, but I liked this meme about working with Excel. And I don't want to bash on Excel. I don't want anyone to feel bad if they use it. Really, the issue with that first document is that it's trying to do three things at once, right? At one level, it's trying to be a place to store data. On another level, it's a place where you're doing computations. And then on a third level, you're trying to make it visually interpretable. So it's also a report. So when you have these three competing things happening at the same time, you can cause a lot of issues because everything in this environment is very reactive. You change one thing one place, it's changing something somewhere else, and it's hard to keep track of all of the things that you're doing. And if someone else picks up your work after, there aren't comments necessarily for each thing. They may not know why colors are there. So how do we avoid this is the point of this talk, and that's reproducibility, which is great, right? But how do we do that? What does that entail? We thought about this and we talked about it, and we thought that really there are two kind of levels of thinking about reproducibility. There's this kind of abstract level where you're really thinking about the knowledge organization and how you're classifying things and how you're keeping track of things, which you can either be informed from best practices or your niche use case where you're thinking of the best way that you can organize those things. And then there's also tooling. There's like things that you can use, packages or functions or documents like R Markdown to help you do that. So we'll kind of separate things at these two levels so that we can like slowly move through this this sort of complicated way to think about doing analysis work initially, because it seems overly complicated, right? So we'll split our time between those two levels, the conceptual thinking and also how that is implemented practically in our studio. So let's start at least with like what we've noticed as a paradigm shift in programming, where you used to have this R script that you would use and do all your work in. It would be commented. There's no way to distinguish text. There's very limited formatting. It's all sort of light gray and just a blob above whatever code you're writing. And it's all source. There's no presentation layer. And that's usually the thing that's kind of attractive about Excel, right? People like it because you can add colors. You can make it readable and enjoyable. And that's what our Markdown can provide. It's a mixture of the Markdown and the code. So you have this ability to format text, to create structure, to use color, and to document while also preserving the code so that it's sort of kept separate from that, right? They're not mingling together. So it's source code, but it has this presentation layer, which makes it, I think, an attractive choice, especially to people that are used to using Excel.
And I'll just make a comment here that this is kind of a new paradigm for a lot of data analysts. Like 5 years ago, if I was working through a new data set and just kind of exploring it, I'd be writing code and I'd be like putting little comments here and there like, oh, it looks like there's like a lot of outliers for this variable. I'm just going to remove those for now and deal with those later. So I'd be kind of keeping track of my thoughts, but it would be as comments. So you have code with embedded comments. What we're now getting into is a paradigm where you've got sort of a running commentary with embedded code. So it makes it a lot more readable because you can almost be like writing a diary of like, as you start to explore a data set, like, all right, so it looks like I've got these outliers. I think I'm going to remove these, but I think I want to come back to this. And what's really nice about this is you can then take this document and send this to someone else, and they can see exactly what you've done and what choices you made as you were processing this data set. As opposed to sending someone an Excel spreadsheet, like, have you ever like looked at this bloated spreadsheet that someone sends you and you're like, what did you do with this data? It's really hard to figure out what was done without like tracking through multiple formulas and stuff.
Jumping on a call.
Yeah, right. So
Right.
the idea is to have a document that will be a mixture of, presentation, but also code. And the code, if you go line by line through it, you should know exactly what that person did with their data. So that's kind of the idea behind reproducibility.
Right, and here's sort of an example, right? So on the left side, you have this R script. And so the code is doing the same thing, right? But in the R script, you have these comments about where things are coming. And it's not very inviting to read it. On the right side, though, you can have section headings. You can have things be bold or italicized. You can have LaTeX for the formula if you're doing a lot of statistical modeling, so that for folks that are math background heavy but not programming heavy, they can follow along with what you're doing. And you can also separate in your text what is like the code elements by adding the monospaced font so that it sort of reads naturally of what it is that you're doing. And this is just a really basic example, but you can take this much further. And like what Lauren was saying, my take is that the notebook is kind of cathartic. It is a computational powerhouse, but it's also the way that you document things like a diary. And you should be preserving all things, successes and failures, because if you think something's going to work and you try it and it doesn't work and you delete it, chances are 6 months from now, you're going to try it again and it's not going to work. And then you'll remember, oh yeah, I tried this 6 months ago and it didn't work. But by preserving that in your document, you can save yourself, your future self, time from thinking you can solve it in a novel way that sort of intuitively made sense to you. And so that's my take on this is to preserve everything, to document the entire process from start to finish. And so one of the ways that we do this, at least practically with the way our Markdown works, is it has code chunks. There are 3 backticks, brackets, and an R. And then there's R code that goes in between this, and then 3 brackets again. This is what separates your code from your Markdown. And the ways that you can preserve the work that you've done while also not including it in your report is by telling your code chunk whether or not you want to evaluate it, which means run this or not. So in this sense on top, it says eval equals false. So what we're saying is, here's some code, but don't run it. And so in this instance, this is a great way to preserve whatever you were doing before that isn't working. And there are going to be times in a project, in an analysis project, where you think that you've done something correct, and it turns out it's created side effects that are unintended down the road. And so by, one of the ways that you might think to mitigate this is by removing it from your report. But it also is important to remember that this was, a way that you were trying to solve this issue, and by just saying don't evaluate this, you can preserve that so that people can understand how you're approaching it, what you were thinking, and how the project's evolved over time. Otherwise, people are going to look at your work, and this probably happens to you too, where you look at someone's project and all it is like success and win after win. So you're like, wow, this person makes no mistakes. I must be really garbage as a programmer or an analyst. By being honest about where success and failure happens, I think that's important for analysts to see, because they can understand where you're coming from, because we all make mistakes. Most of the time, you see TV shows where the hacker is just like nonstop working, really crazy. I mean, if someone were to watch me live coding, there'd be lots of like 5-minute pauses where I'm just looking at the screen like, why isn't this working? And it's important that people know that everybody goes through that, right? The second option here is whether or not you want to include it. So this is a great place if you want to run something, but you really don't want it to be in your report. You can designate your code this way. And so you can see how both of these things can work together also, whether or not you want to evaluate it or whether or not you want to include it. And this is the way that you can, for the analysts that are going to work with your work in the future to understand where you're coming from, but then also the consumers of your information are not necessarily going to care about everything. So you can kind of separate those things, but do it all in one place. And there are many customizations with code chunks. There's full-on like parameterized reporting, but that's probably well beyond what we want to dive into right now. But those two options I think are the most useful, especially when you start diving down the reproducibility track. So there's a toy analysis, and you can see this is just a really simple directory structure here. In the examples folder, in the Star Wars folder, there's this R Markdown notebook. If you want to open it, let's kind of break into groups. Like if there's somebody that has already cloned the documents and things are working, maybe you can work with them. And it has an example of just a very basic visualization using some Star Wars data that comes preloaded in dplyr, and some other like very quick little dplyr code chunks that you can turn into another visualization. So spend some time thinking about how you might want to approach analyzing that data and how you would communicate that in the text above. And this is a great time too to raise your hand and ask questions about how you might want to do that, and we can kind of float around and help.
And actually, maybe before you get started, we'll just maybe kind of introduce you to what you're seeing when you go in there. So you load up this R Markdown file. I'm sorry, it's very small and hard to see here, but it's R Markdown because it's .rmd. And the first thing you see is there's a little bit of a header material, title, author, etc. But skip past that. And then there's sort of two kinds of data that you've got here. So you've got just like normal text and stuff, right? So like this is going to be a heading that says data. This is just going to be a line of text. So this is just like normal text that could be part of a report or part of a website. And then intermingled with that, you've got these little chunks of R code, which are highlighted in gray. And so the idea behind this is that in a moment after we've explored this, we're going to hit a button in RStudio. It's going to take this document and it's going to turn it into an HTML web page. although it doesn't have to be a web page. It could be turning it into a PDF report. It could turn it into some slides. The idea of our Markdown is it's kind of format neutral, so it can become whatever you want it to become. But so when you click that button, it's going to take this text and it's going to kind of run this code. And when it runs the code, if the code produces a plot or a table, it'll stick that plot and that table in the middle of the text. And if it doesn't produce a plot or a table, it just kind of runs the code and keeps track of the variables. So that's the idea behind our Markdown, is you've got like normal text like you would have in a web page, along with code that when you hit the button, it's going to evaluate that code and produce whatever kind of figures or tables you want to stick into the document.
Mm-hmm.
Okay.
And also when you're in, sorry, I'm looking for the mouse. Where is it? There it is. Like I said, I am losing my vision. So there is a little button here you can click. And this gives you sort of like a table of contents. So like as you add more like nested elements, so you might have a data like heading with one hash symbol. With two, you can say, well, this is where I'm reading data. There might be another one where this is, you know, data from 2016 or data from 2017, right? And so in this little column to the right, it'll keep track of that so that if you need to navigate to different sections of it, you can just kind of automatically go to these places. So this is another way of sort of making things easier for yourself, right? As you navigate through your own document.
You want to explain the run chunks?
And the great thing too about this is that you can run the code in our studio, and it'll display it right underneath. Oh, so we have to load tidyverse first. So make sure you have tidyverse loaded. And now we can run Star Wars data, which looks like this, and it'll spit it out in this easy to navigate data frame that you can click through and you can filter through, which is very, very handy. But if you're really not used to that and you'd like to look at it more like a spreadsheet, you can also use this little pipe symbol, which means that you're taking what's on the left-hand side and you want to put it in as an argument to the function on the right-hand side. So RStudio has this view function here that you can run, which will open a tab, and then you have more of a spreadsheet style way of looking at it if that's more comfortable. And this plot here is just it's a very quick ggplot. And so you can take this same code if you want and add it to the other sets of dplyr code here and kind of create your own visualizations. You don't have to do this either. You can create your own if you're more comfortable with R and dplyr and you want to create your own analysis with the Star Wars data that you like. You can do that too. But take some time with maybe your neighbor and think about, even if you're not going to run the code and do that, how would you document what's happening? And if you need any help because you don't know what the code means, you can raise your hand and we can talk about that.
Yeah, Philip.
Okay. Yeah. So if you look right here, so in examples, there's a directory, and then there's the Star Wars directory, and then there's the Star Wars analysis.rmd file. So remember too that you're not just doing this for someone else, like you're doing this for yourself also, because at some point you will return to some work that you did 6 months ago and you will not remember ever writing any of this. And if you don't have any documentation of what you were thinking, it will be very painful. And so really this is a way of exploring how you would describe this simply. And when you get in the habit of doing this often, then you don't worry about this anymore because you know you've documented how and why you're thinking about it. for the future. You're just kind of covering all your bases. And so like one example is, if you're looking at, you're inspecting the data, you can say that you want to run the dplyr glimpse function on it, because you just kind of want to, that's another way of taking a look at the data frame. You can run, the summary function also. But in any function that you'd want to run, you just talk about why you're doing it. Like, why would you think that that's a good idea? Or why would you think, so like if you want to get descriptive statistics because you want to see the spread of the variables, that's an important piece of information that you can document in your R Markdown file here. It's in dplyr. So when you load tidyverse, dplyr is automatically loaded. And you can even load it in without, even if you don't load the package, you can say, Star Wars, and assign it by dplyr : Star Wars. And you can even, say that you want to call this data. And so now when you run the data variable, you'll get the Star Wars data. So there's just like other ways that you can do this also. If the actual coding part is a little overwhelming, you can also just open the HTML file and take a look at what is already in there would look like. The HTML file you open in your browser. Yeah. Yes, exactly. Yeah. Mm-hmm. Yeah. So the reason that I had to do that is because if I want to show you what a code chunk looks like, R Markdown wants to always it sees that and it's like, I do something with this. I compute things with this. So putting a chunk inside of a chunk doesn't work. It'll throw everything off. So I'm using HTML and the codes for those backticks so that I can tell it it's not something to evaluate at all. Like, don't even, just completely ignore it. It's a way of, so I can show you what the eval looks like eval equals false. Mm-hmm. Yeah, exactly. Mm-hmm. Thank you. Yeah.
When you are done running all the R code chunks, assuming it has worked for you, and you want to see what this whole document looks like as an HTML web page, you can come up here to this knit button and just click that. And it will go and turn the R Markdown into an HTML.
So it might be possible to have some things installed. So this is the issue of environment. You're setting up your program. Lots of things going wrong. Each person so you have to do some like research and just like and seeing what it could be something. I doesn't know how environment works. I use analytics for my development. Alone probably better. But even if you're not able to, you can open the HTML files in your browser or play with those too. Yeah. We'll kind of move forward. So if you're having some issues with doing the live coding and you're not able to access your program, there could be an issue with your programming environment. You'll have to spend some time at some point looking at your environment and some of your variables and making sure that in your path things are set up. That's a little outside of what we want to do here. So I think what we'll do is move forward from this point, and you can open the HTML files in your browser so that you can get an idea of, what we're producing. And you can always come back to these slides later because these slides themselves are also in R Markdown. So this is just like another example of how flexible learning this can be once you get past the initial struggle of learning not just R Markdown, but how R works and how programming works in general. So the interesting thing about these files, as it knits it into an HTML file, like we just showed earlier, is that this is a portable document that contains your data and analysis and output that you can then email to a colleague, collaborator, or a boss that kind of encapsulates your thinking about it and the way that you want to present your work. Does anyone want to share some takeaways from doing this exercise? Maybe something that stood out to them? Yeah? It is very confusing, yeah. It's difficult to, it's not easy to jump in to this right off the bat, so definitely don't feel bad. It is confusing. Exactly. So the difference between a Jupyter notebook and an R Markdown document is that R Markdown is plain text. So if you are in a terminal environment and you're using something like Vim to get into that like text of the file, it's all just plain text. With Jupyter, if you're familiar with JSON, everything is in a JSON object. So if you're going into the text version of a Jupyter notebook, it can look really confusing.
So if things are not working for you, packages are not loading, let me know and I'll come over and help you if you're still having trouble. Also know that this is an experience that everyone, myself included, has gone through, especially when I was a beginning R user, a lot, but also even now as a slightly more advanced R user, continue to have these experiences every day. So this is kind of an unfortunate
Rite of passage.
yes, an unfortunate aspect to the current open source data ecosystem at the moment is these kind of experiences. And it's kind of something where you got to get over the learning curve by using these tools. You know, for me, it took, you know, using this stuff fairly regularly for a year or two before I really started to get comfortable with it. So this is a normal experience.
Does anyone want to share any other takeaways from trying to do that? Mm-hmm.
Yeah. And if you, maybe you already mentioned this, but once you have knit that file to an HTML, it creates the HTML file in that same directory. And all of the data that went into that data analysis, any chart that you've got, that data is embedded in the HTML. So you could then take that HTML, upload it to a server somewhere, email it to your colleague and say, here's an analysis that I just did. So it's very portable. And that's kind of the idea behind R Markdown.
Yeah, and like you were saying, you can copy the chunk. If you look at what your colleague's doing, you're like, oh, that looks like something I can build off of. You can copy that into a code chunk and start playing around with it and seeing if you can get to a different conclusion, or maybe it sparks some interest. And it's really great for exploration because you're able to do all these different things quickly with it and just kind of see the immediate response of it. And you don't have to save it, right? You can just kind of try things out until you've figured out if it's working or not. And so that's also like oftentimes when you're in the danger zone as well, because when you're playing around, you're not really documenting what you're doing. So it's important, like as you're doing that, to think if you're going down and spending serious time thinking about something, like that could be a good opportunity to document exactly your process. So let's talk a bit about naming conventions, because this is also really important when you're working with lots of scripts and files and directories. You know, there's lots of conventions that you can use. There's best practices. There are things that, you know, you can look up that will give you 100 different ways to do this. But just remember that there isn't really like a canon for this, in the sense that like there's a right answer. From a knowledge organization standpoint, this is arbitrary, right? We're drawing lines in the sand and saying this is a division of something. So the ones that I'm sort of going to share with you are ones that I've been using for the past 3 or so years on projects that have been going for 3 or so years that have been really useful. In your project root, it's great always to keep things separate in directories that make sense. Having a data directory, having a docs directory, a models directory, a notebooks directory, and a reports directory. And what these things are: data, obviously this is where you store all your data and your metadata. Docs is where you can store text documents that are about the project. There could be some documentation you received, you know, from someone asking you to do this, or explaining where the data comes from, or maybe a report that you had to put together of like putting together exactly what is going on. Why is this project relevant? Maybe it's, you know, grant documents or something, anything that sort of gives you like a sense of what is this project all about. The models directory is where you can save and store any of the models that you're developing, or the ones that you're building, or the ones that you're deploying. So it's a good idea also to keep those separate. Notebooks is a great place for you to put your R Markdown documents. And reports is where you can put the output of your R Markdown work. So say you have a colleague that says, I only want your work in Excel. You could do your work in R Markdown and then write all of the data frames and tables into Excel. So you can then say, I want to save, you know, this output into the report section. Or if you have a final R Markdown document that encapsulates all of your work cleanly, and you want to save that like to PDF. If you have someone that doesn't want an HTML file, you could do that as well. And oftentimes you'll want to save the visualization separately as image files in case you want to copy them into emails or put them into some other format, and you can do that as well. With data, oftentimes there's a process, right? You receive data, maybe you have some external source that you can say, here's some SQL queries. This is how I'm getting the data, right? Raw is a great place where you can say, I'm not touching it at all. This is just the exact like representation of whatever query or whatever data I'm receiving. Interim is a great place for when you've maybe joined different data sets together or bound them together into a sort of staging area where the data is close to being processed, but it's not quite in a tidy format yet, or it hasn't had different variables added to it that are transformed from doing some of your analysis work. And then tidy is where you can store the fully processed data that needs no other editing to it. This is data that is ready to start modeling on, or the data that you use to start visualizing with that doesn't need any more edits to it. And if you don't have to, if you want to dial the granularity back, that's fine, because this is your project, right? You are the one deciding how you want to do this. I think the most important directories would just be a raw and a tidy one, if you want to keep it simple at first. In the docs directory, you can set a section for references in case you have a document with lots of exhibits or footnotes and things that like if you want to keep things clean. I tend to like folders, so you might not like them. You don't have to include this. This is just something that I tend to do. Like if I have a brief where I'm proposing some project and I have different sources for like footnotes and things, I'll put them in a references section just to keep it easy. And in reports, you can also set a separate directory here for your figures if you want to have a directory that just contains the output of ggplot. So it'll have all of the PNG or JPEG images of your visualizations there so that they don't get too crowded with the reporting that you're doing. When it comes to the workflow of your R Markdown documents, I like to number them like 00, 01, 02, 03, 04, etc. And what I like to do is think about these R Markdown documents as having like fundamental jobs that I want them to accomplish. And so each one of these is sort of like a relay racer that is going to be like taking a baton and passing a baton somewhere else. So in the read and join data file, this could be a file where you're taking data from different sources and you're kind of putting it into one data set, one CSV file that is still a bit rough around the edges, but it's mostly there that you can then write to your interim data directory. And then when you're transforming and you're writing it into a tidy format where you've done all of the data munging and cleaning, and it's in a format that you're happy with, that you can then model and visualize with, you can take that from the interim directory and save it into your tidy directory. And then as you're doing your model pre-processing, there could be some other stuff that you need to do depending on the model you're using, where it might need some slight tweaks to it, but it's not necessarily about the shape of the data. It's about the model that you're using. You can do that there so that you're just sort of linking each of the steps of your work together to where you end up at the end with a document that concludes the work that you've done and kind of expresses the decision that you've come to because of the analysis work that you've done. And this is it's a habit just to get into, I think, that would be helpful, because there are going to be times that you think that you're naming it clearly, and when you return to it, you're not going to know the order of how these things should be run. Other than creating one R Markdown document that does all of this stuff together, that will take a long time to run. And if there's an error somewhere in the middle of it or somewhere 50 or 40% in, will be really hard to debug. So this is sort of like taking functional programming a bit and thinking like, okay, if I were going to write a function that does this work, like what would that function be? Something simple that takes the input and gives you the output. Sorry. And if you want to have, this is just summarizing, each one of these numbers is, you're giving it a job so that there's this logical order. Even if you don't know anything about what those scripts are doing, you get a sense of how they feed into each other. And you may have separate sections, right, where there could be, this project B that has more of a geospatial like dimension to it, but you don't want that intermingling with the other project. They could be related, but you want to make sure that the workflow is separate. You just create subdirectories and go from there, and make sure that in your README you're talking about why you're doing that. That way, in the future, you're happy with yourself and others are happy with you. And it's up to you, like how much nesting and structure. It's just how comfortable are you with granularity, right? It might not be that important to your project. So you'll just have to think about it on your own and decide what level is required for your work to be reproduced in a way that a stranger gets from point A to point B. So striking that balance can be difficult sometimes. So now that we've kind of talked a bit about like the conceptual stuff about how this works, we can start talking about like practical ways you can do that. So use this as a package that has a lot of great advantages once you get comfortable with working in R Markdown. For some of you, you may need some time in R Markdown to kind of become more comfortable and familiar. But this is a great way to get projects up and running quickly. You can use this package to store a list of all of the ignore files that you have in your GitHub directory for your repository. So if there's specific files that like based on the style of how you work, you want to always ignore, you can keep them there so that every time you start a project, it's good to go. All of your customizations are there. Like this sort of reflects one thing that I do often is I have a scratch _ naming convention so that if I'm ever tempted to save something as like 02 analysis 0B, which is not good, I can test things out in this like scratch document first, and it won't get tracked by GitHub. And I can see and play and do the thing that I want to do. Like maybe I'm doing this all wrong. This whole thing needs to be refactored, meaning just completely redone. I can test that out and see how it works and then incorporate that into the file that it needs to go into, so I can maintain what I did and how it's changed. You can create the path, you can use descriptions, you can set the ignores through that list, you can create licenses, you can create those directories that I mentioned, all in one quick command. And so maybe we'll skip doing the use this package, since the exploratory Star Wars practical exam kind of didn't quite get off the ground. But just for your reference, here's a bad pun. You can use this example. In examples, use this, create project. This is just that file that I was showing you earlier. You can take this in RStudio, run it, and it'll create your whole project structure. But when you do this, it's going to create a GitHub repository. It's not going to create a GitHub repository, but it'll set Git up, a license, and all those directories. So as you start learning this and get more comfortable with it, and you have a structure that you really like that represents like the work you like to do, and then you can kind of have your own create project script that does that work for you. So we'll move through this. So let's give you some examples instead of doing work in the RStudio IDE. So there's a lot that you can do with R Markdown documents beyond just quick analysis documentation. You can create websites with this. So this is kind of like shameless self-promotion, but I wrote my website in R Markdown. The whole website is R Markdown, and it's hosted on GitHub. So that's something that you can do. You can see what it looks like and then what the code looks like. But also the documentation for creating R Markdown websites is very good. And then I wrote a blog post about how to do it if you want it to be a little more like concise and to the point. But you can do, these are very, very powerful tools. I think we mentioned it already that these slides are created in R Markdown also. So any code we write on these slides would work and look exactly the same way in an R Markdown document. It would look and work the same way on a website. So especially if you're an analyst that works by yourself and you don't have a ton of support and people that you can lean on, by leveraging these tools, you can do a lot of work at the same time. You could take the exploratory work you're doing and port it into different mediums. So we can take a quick look at how this works. In the examples ISLR directory, there's this index.html file. If you want to open that, I don't know if anyone's familiar with the ISLR. It's the open source textbook. It's the Introduction to Statistical Learning with Applications in R by Trevor Hasty. It's a great way to learn statistical modeling in R. So I started taking notes going through this book, and I did them in R Markdown. But what you can do is you can take those notes and then put them all together into this format here where you have everything. There's a navigation bar on top. You can go home. So all of these things are linked together, right? I put the YouTube links for each of the sections, links to the slides. You can click this and go to the different chapters. There's a floating table of contents. I have custom CSS for the code chunks so that it looks like Solarized has a dark theme. And so you can see that with R Markdown, you can do a lot from creating these markdown tables here to explain what some of these formula are doing, to the visualizations themselves. You can set these little notes here where it's slightly larger and with an italicized font. So the sky's the limit, really. I mean, this walks you through the whole chapter 3, which is a very long chapter in that textbook on linear regression. So all the LaTeX formula are there. You can explore that if that's something that you're into. I like doing that. I'm weird. This is an example of how you can start to add interactivity to your document without creating a server necessarily. So I wrote this, there's a base R correlation function that you can use, and I just rewrote it in a tidy format so that I can create this heat map with it. And this is in Plotly. You can even add in all of these different visualizations. So this is sort of the place that you can get your work to after you've become a lot more comfortable with the tools, so that it becomes like second nature, that as you're writing and thinking, you're just writing it down.
And the R Markdown file that produced this web page is also in that same folder. So if you open that up, you can see what it looks like to actually produce this.
And the way that it works is really simple. So we can take a look. It's weird, emoji outside of Mac looks different, but yes. So the index RMD is, that's where in order for the R Markdown websites to work, you need the underscore site YML, and you need that index RMD file. And so in this this YML file, what you're saying is you have the title of what it is, the output directory, meaning it's just in the root directory already. You have a title for your navigation bar. You have this drop-down menu where you want these options. And you're saying in this option on the navigation bar, go to this R Markdown document. And then just like that, you can run those HTML files like a website where things are linked together. So if you get to the point where your project has grown and there's lots of different layers to this, you can link those steps as a way of explaining from point A to point B, like when you started at the very beginning of your project, how it all works together towards the end. Do you want to go over the?
Yeah, sure. So I'll just show you a couple of examples of how I kind of have used R Markdown professionally. The first one is you can use it to create dashboards. There's a package called Shiny Dashboard, but it's essentially just R Markdown code that produces something like this. And you can define different views that you want in your dashboard. And then every single one of these charts is a little code chunk that takes some data, produces a graph. And in this case, I'm using a package called Plotly to make graphs that are kind of interactive. And then using R Markdown, you define how you want it to look. Where should all the graphs go? What should the layout be? And so you can define the look and feel of the whole dashboard. So this is somewhat interactive in the sense that like you can kind of zoom in on data and you can turn different data series on and off. So you can actually get a lot of functionality from a fairly simple amount of code using R Markdown and Shiny Dashboard. So this is one thing you can do with it. I'll show you a simpler example. Here we go. So this is just an analysis I did. I wanted to look at some of the historical data on reservoir levels in California and see, as temperatures have increased under global warming, do we see those reservoirs starting to fill up earlier because the snowpack's melting faster? So here we go. So this is basically just an HTML document. This was made in R Markdown. So this is all just regular text. You can define headings in R Markdown. You can make things bold, all the sort of things you would normally do in a report. And then here's a code chunk. And this particular code chunk is making a graph using another package called Plotly. And Plotly is just a way of making kind of interactive graphs where you can kind of zoom in. And then here's another code chunk, and this one's making a graph using another package called ggplot. And so then we get to the end and we find that it looks like, yeah, maybe if you squint, there's some relationship between the annual temperature, so that as we get hotter, the reservoirs start to fill earlier. But so this is just a really simple kind of example of a data analysis that I did just to show you've done all this work for your data analysis. You want to like share it and show it off to people in a way that A, it looks nice. B, if they wanted to redo the same analysis you did, all the code is there. And C, it's got sort of a running commentary of what you did the whole way down. So in this case, I kind of made the commentary, you know, it's a little bit conversational, like, okay, first let's make this chart. Now we're going to normalize this variable. And so this is the kind of thing that you could send to someone and say, here's what I did on this data analysis. And they could kind of look through and follow through what you did. And then if you wanted to actually share the actual R Markdown document with them, all the code that you used would be there. So This is just an HTML file. It's being hosted on a site called RPubs, and that's integrated into RStudio. So if you want to put someplace where the public can see it, you can, for free, from within RStudio, you can publish all your documents to RPubs. I think we can even try doing that right now. So here, I'm just going to knit this Star Wars RMD to an HTML. And it pops up in this little viewer, and you can choose to open it in your browser if you want. But from this little viewer, there's a little button that says Publish. And you can say, I'd like to publish this to RPubs. Now, I already have an account set up. You would need to set up your RPubs account. But once you've done that, you click a button, and it literally takes that HTML file, uploads it to RPubs, and now it's publicly available for everyone to look at. Okay, and then as Robert noted, these slides themselves, this is also just an R Markdown document. We're just specifying, okay, where do you want the slide breaks to be? That's really the only difference from what you've seen so far. Everything else, the headers, the code chunks, it's all basically just the same. So I could take this, I could turn it into a PDF document, I could turn it into an HTML document. So the nice thing about R Markdown is it's a way to store your analysis that is completely independent of the actual reporting format that you want to turn it into. All right, and then do you want to talk about Flex Dashboard?
So, yeah. So Flex Dashboard is another R Markdown format for creating dashboards that are also stored as HTML files. So rather than dealing with hosting something on a server, you can create an interactive dashboard in R Markdown. And I just wanted to bring this up. I'm not going to dive into this right now. I put a blank Flex Dashboard document there, and you can read the documentation on the R Markdown website about how it all works. But it's important to ask yourself, whether or not you need a server running and deploying an application to communicate your analysis to someone else. If you don't need to do that, then don't do it, because it's a lot of work. As you'll see, we're gonna later in the afternoon jump into Shiny, and so the learning curve kind of it precipitates a bit. So if there's a point at which you feel like it's not necessary to do that, then you don't have to dive into that. You can really explore R Markdown and really get the best. You can really squeeze all of the productivity out of it, from, like we already went through the documentation phase and sort of showing people and demonstrating them like how you did your work, to building a dashboard that can summarize all of your work in a clean and easy way. And does anybody have questions?
If you want to see the Markdown that produced these slides, that's in the GitHub repo also. So if you go out of the examples up one directory, you'll see there's the HTML for the slides, but there's also the Markdown for the slides. And so you could load that up. And let's see here. So
then you can get to the point where everything you do is in this IDE.
Here's one slide. Here's another slide. So the slides are separated by these three dashes. There's some R Markdown code telling it, okay, I want the text in the slide center.
Right. I want the color to be inverted so that
So this is just normal text.
Yeah.
And so there's no actual R code in this R Markdown. So here's an example where we're just using it to make some slides. We're not even using it to run any code. But if you wanted to just show some code without actually executing it, you could put a code chunk in. Let's do that now. Let's go right up here to the top, and on this first slide, we'll just put a code chunk in. We'll say insert R, here's some R code. And this isn't even R code, but it will display it as if it is R code.
They'll try.
Although, oh, you're right. I should do something like, let's say 4 plus 5. Let's knit that to an HTML. New package called email.
Oh, so you don't have the emoji package. I care
Oh,
about emojis,
there's an
so
emoji package.
I have the emoji
Okay.
package.
There's always something.
I like emoji and I put them in the slides. So actually, it's one of Hadley Wickham's packages, and it's just called emo. So it's actually really funny if you Google like emo Hadley, because there'll be a picture of him smiling and then other people that look really emo next to it, it always makes me happy.
Oh, I need to actually load the image.
Yeah, you'd have to install it.